Okay, I'll show you n-dimensional list slicing. So we'll make an n-dimensional list, and so I'm going to make a function equals amplitude times sine of time times frequency plus phase, and then fill a table called data equals table of that function. And we have 4 variables, 4 dimensions, this amplitude, the time, frequency, and phase. So we need 4 different iterator structures. And so I'll use the outer one as I. So amplitude's going from 1 through 6. Frequency is going from 1 to 3, for example. Phase is going from 0 to 3. And I'll have time going from 0 to 10 at an interval of 0.1. I'm going to put a semicolon there because it's going to be a huge amount of data. And then check our dimensions of the data. And here are the comments of the data. It's 4-dimensional data structure, so we see these 4 of this list of 4 dimensions here, 100 time points. And so if we want to slice out part of the data, let's say slice equals data 6, for example. So now we've sliced out 3 dimensions. So that's 101 rows, 3 frequencies, 4 phases, so all the frequencies and phases for just the 6th amplitude case. We can't plot that at the moment because or easily using, so we just want to plot a 2-dimensional slice. So list line plot slice, and then we'll do a plot range -6 to 6 for our amplitude. And I'll change the slice. We'll say we'll use the 6th amplitude and the first set of frequency values. So we see all phase values for that given set. So we can do the small amplitudes or the medium amplitudes, so on and so forth. Or we can do one of the phases, or all of the phases, for example. Or we can do, let's say, one of the phase values and all of the frequency values, and we can change the amplitude. So you get the idea of how we can navigate these data. Change this back to 6 so it's easier to see. And then finally we can manipulate our time index. Let's say if we just want indices 1 through 45, we see 1 through 45 for the 6th level of amplitude, all of the frequencies we chose, and the 3rd level of phase. And you can look at the dimensions of the slice. So the dimensions of the slice in this case is always 2-dimensional.